All right, yeah, welcome to our talk as well. So as you said, today we'd like to talk about our experience with how we built basically our semantic search in the aviation safety space. Before doing that, short introduction about both of us. So my name is Dad. I've been in tech for around 15 years already, done quite different roles. So worked for Pivotal in the past. This is where I also met Dennis. Then headed a data team at Idealo, Axel Springer, and also had a short stint at Beams where we basically work on that project together. And now basically I have my own data consultancy.
Hello everyone. Yeah, my name is Dennis. I've been in the industry now for like around about 15, 20 years, depending on how you count. And as Dad already mentioned, we met each other at Pivotal Labs. I started back then in San Francisco. After I didn't like San Francisco so much anymore, moved back to Germany, worked at SoundCloud. Fun fact, actually, like if you move your finger on this like little sound wave thing, the timer thingy goes up and down. That was the first thing that I did back then. It's still in there, quite nice. And now I work at Beams, which was a startup that started during COVID in travel. Not so great. And then we pivoted around like a few times, and now we're in aviation safety, and that is also what this topic is going to be about. Right, so why this talk, right? As you can imagine, safety is crucial in the aviation sector, right? So nobody would be flying a plane if we wouldn't know that it's safe. And like quite famously, we all understand that flying is actually more safe than driving a car, for example. But that doesn't come for free. It's actually a result of the industry's commitment over really decades to ingraining safety in all of their, in the entire stack of the organization. There's all sorts of systems that come together, like flight safety monitoring that sends myriads of data. There's all sorts of other systems, and quite importantly also, there's people involved in this heavily. And these people contribute to safety by writing a lot of reports. A report is essentially just a piece of text. So everyone from ground operations to the pilot to the cabin crew, they pretty much every day write multiple of those reports, from the smallest detail, like, I don't know, maybe the trolley has a wheel that is stuck, maybe a bolt went loose somewhere, whatever it might be. People write their reports about like during an approach, wind shear, whatever it is, right? And as you can imagine, it's a free text form, so someone actually has to read through all of those and analyze what has actually been written in this, get trends, so like we go into risk management to get quantitative data out of those qualitative data to predict like where do we actually have the biggest problems in our airline. And these things are at the moment mostly manual. Right. How does a report look like, or how does a report get into the system? There's one little tool that we wrote, which is called Co-Reporter, which tackles one of the big problems that you have with reports, just like a little aside, which is when you write a report, you're kind of like under time pressure and you might not get the full picture in, right? So you're just like writing something, and then if someone actually has a follow-up question, it might take weeks because it first has to get analyzed, someone has to read through it, get back to you, and yada, yada, yada. And so there's this little tool here that we want to showcase for a second, how this could also look in the future.
On our flight from Berlin to Dubai, we encountered several issues. But one thing that stood out was when we landed, we almost hit a drone.
So now it's being analyzed, basically.
At 2,000 feet.
Analyzed again.
No, there was no visible damage to the airplane.
And one more analyzation. All right, so you get the idea, right? A report, free text form, just flashed up really quickly here. What then happens is basically the system in the background understands what kind of report is coming in, what kind of data has been provided, what kind of data might be missing, so it can ask follow-up questions. And then do some analysis as well, which ultimately, how do I go to the next slide here now? Right, ends up in a report that kind of will look like this. So just that you see what we're dealing with here, right? Free text, some AI-generated summary here, high descent rate managed with flaps 15 and gear extension. You can already see like it's highly technical, the way that people write these reports, because often they talk about like very technical stuff. And then where we would come in is essentially, if you see the bottom part here, to make these things more quantitatively analyzable. There's different kinds of classifications, for example, that we want to analyze about it. So there's AJAB, which is just an industry standard to get a common classification across the industry, and then we have our own things here as well for risk management, mostly hazards, so what kind of things contributed to the incident happening. Fatigue, for example, here being actually like a very important thing in the airline industry because it affects many different parts of the organizations, from scheduling to training to all sorts of different things. Right, so that's just kind of an outlook on all the different things that can be done in the aviation industry and a lot of things that we are doing here. I'm not going to talk about any of those really. Feel free to catch me afterwards if you like. For today, we want to focus mostly on AI search, so this little box over there. And one possibility could be bird strikes in Berlin last week, right? So just as a thing. What makes search so hard? It seems like this is kind of maybe already like a solved problem, right? And to some degree, I guess it is. But what makes this particularly difficult is that, as you could already see, there's a lot of technical jargon. There's a lot of abbreviations. These abbreviations also quite often, they're not consistent between different airlines, right? You might have one abbreviation that means one thing in one and a totally different thing in another one. And if you just use traditional LLMs without any specific training, that kind of breaks them a little bit because they just don't really know how to deal with those information. What you could also see, maybe if you've read a little bit through this other report, actually that was quite good, sometimes they're way, way more confusing, is pilots or people are often asked to write these reports outside of their core working hours. So they're already stressed, they kind of are rushed, and they want to cram in as much detail as possible. So it's a very dense language, and honestly, when I saw the first reports, I could barely make any sense of them. So it's a very dense information. Then you have, of course, different ways to phrase anything. So in this example, some might say, well, we had a bird strike, which is a common terminology, but other people might be like, well, I actually saw it. It was a flock of geese that hit the engine. And if you want to search anything because you want to run an analysis across like the hundreds of thousands of reports that you've been getting, you don't want to end up having to write like 50 different variations of the same search terminology, of course, right? You want this thing to find semantically identical pieces of information. The industry, of course, as we all know, it operates globally. English is the de facto language, of course, but that applies to the cockpit. The more you move away from the plane itself, the more you go to ground operations, the less people might be fluid in English. So you still have a lot of variety in different languages where people just feel much more comfortable in writing. Then you have all sorts of other like issues, of course. So like a no stall warning might not mean that a stall warning has been triggered. You have like this unstructured freeform text, and the terminology is constantly evolving because you have new planes coming in, you have new technologies coming in, you just have new types of problems that come up all the time.
Yeah, so how did we solve it? Before we go into our solution space, wanted to talk shortly about software philosophy, or because we both come from a software engineering background, we also have a little bit of philosophy how we actually tackle the problem, right? The first was also very important for us, and you will see also why we made that decision to use pgvector, right, on RDS. Because of that, because we wanted to start simple and add complexity later, right? What does it mean? So obviously, you probably already know all these fancy vector databases that are around, right? Like Quadron, VV8, and co. We could have gone that direction, right? Instead of going to pgvector. But basically, our philosophy was not, the tech is a tool that we want to use to solve a certain customer user problem, right? And we wanted to do it as fast as possible with basically the less complexity in place, right? Because our architecture is on AWS, right? And especially we use RDS, but basically Dennis will also go more in detail about that soon. Then obviously we are working in very test-driven settings. That means writing tests first. We do a lot of pair programming. Basically, it's 90% pair programming. In this case, security was also very important for us, right? So that data is stored in a proper way, right? You will also see it in our ingestion pipeline, right, where we do PEI removal and so on, which is we want to be compliant, and obviously. I think it's a little bit of buzzword, right? Do the right thing, do what works, be kind. It's something, that we ingrained from our bit of pivotal time, right? That, just deliver what works. Okay, yeah, just to go shortly into that, we are in a PyData conference, right? So probably, you probably all heard of retrieval and reranking. Hands up if you don't know about it, but I think you probably all. Okay, so not everyone knows of it, but yeah, most of you probably know. How does a search problem usually looks like these days, right? You have a query, right? A query could be EGG temperature, animals, mid-air collision, or bird strike, geese strike, right? What Dennis showed. You have a lot of documents, right? In our case, a lot of documents in unstructured form. And now we have to make sense of it, right? We want to basically filter out all the important documents and prioritize them. And the way it works, basically there's a retrieval step, right, where we putting all documents in there, we're creating embeddings, right, for that, and then we have a similarity matrix where we basically retrieve these documents. And then once we have this basically filtered document set, right, that is prioritized already, we want to re-rank them, right, according to what we actually really want to have in terms of the query that we do.
Yeah, just like a little bit of an overview into our architecture. Fortunately, the industry has also matured, the aviation industry, in terms of what they deem a reasonable setup. Unfortunately, we can work on AWS. So this is just like a rough overview here. So we're using pretty much everything that AWS has to offer. Just at the very core, our application is a single-page app that then talks to a backend, which is in Python as well, using Fast API, if anyone cares to know. And the entire backend relies heavily on Lambdas, for good and for bad, really. So even the web part, the Fast API piece, is in Lambdas. And being on AWS has had like implications, of course, as well on the technology choices that we could use or chose to use then for the search piece. So we are on RDS, we're using Postgres as database really behind an RDS proxy. And
okay, so I already said that we use RDS for that, and if you know a bit of AWS services, it's a managed Postgres instance, right, which handles all of the stuff for us, like monitoring, backup, and also if you need to rescale, which is quite good. And luckily, since 2000. Okay, I think this is wrong, 2023, because that would be a very, very long time ago. They also support pgvector via RDS extensions, so that means, you go into your admin portal with your admin rights, right, and then you can just create extensions. And this is quite nice because pgvector basically offers everything already what Postgres would offer, right? So it's basically asset compliance, has point-in-time recovery, right? You can work with SQL, which is really good for us, and it's open source, right? So this is also nice, and it offers a lot of different distances that you can use, like L1, L2, cosine, but also supports indices, that are quite basically state of the art, right? Yeah, a little bit of getting started, but I mean, I think the best thing is you obviously can go to the documentation of Postgres, right? They are quite thorough. So basically, if you want to work with pgvector, you just need to create a table with basically an ID, right? And then some embeddings, and then you can insert a vector, right? In this value, usually what you would do is you would get an embedding provider, for example, in this case, maybe OpenAI or Anthropic. And then once you have that, basically, as I said, you just do SQL, right? So you just do a query, right? And then order it by some distance metrics. So this is very convenient because you basically writing SQL. A short deep dive into indexes. So Postgres supports two types of indices. So indices, obviously, you know from relational databases, you need to set it up because otherwise the query will be very slow. Postgres supports two of them, which is a hierarchical structure like HNSW, or more like a clustering approach, IVFFlat, right? Both of them have different settings and options and so on, right? So, for example, HNSW, for example, is slower during build times, but in terms of performance and precisions, it is better, right? Whereas IVFFlat, for example, you don't even need to, you need to load in the data, right? And then it's kind of k-means, right? It clustered it into sublists. And then basically you can do the search. Somehow in our case, IVFFlat was better in our case, but you know, it depends on your data, right? How you actually structuring it, and also the different settings, what you can do.
Right, so back a little bit to the architecture and our pipeline of ingesting these reports, and like a little bit of an info on what we actually do with those. So as I mentioned, a lot of it is based on AWS Lambda. That kind of makes it really nice that you can have a pipeline set up where different steps run in like individual containers, and everything is being orchestrated by an SQS queue. So it's all event driven, also for updates, and talking a little bit about that later. So that you get a little bit of a feeling like what we actually do with these reports, right? At the end of the whole process, we want to have these embeddings so that we can then use them for search. We've also, over the course of time, used them for different classification problems sometimes. So different use cases for it. Search is now the most dominant one. What happens is our customers send us the reports in various ways, whether it is via S3 buckets because it's in bulk, or whether it's like real time over web. The first step is always PII removal to be compliant. It depends on which airline it is. Sometimes for some we have some small models that actually run on their site already, so that they can send it to us already pre-PII removed, and we may or may not need to do a second step with some more powerful tech. But after that happens, we also do translations and all these kind of things, as I said, because people might write in all sorts of different languages. After that, we use Azure OpenAI at the moment. So we started with Ada 003, but then eventually now ended up using the text embedding 3 large. And via empirical measurements for our purposes, we basically found that with a dimensionality of 2000, that seems to hit the sweet spot between precision and recall. But the differences weren't really that large between the different ones, to be honest. Yeah, and then everything ends up in RDS.
Yeah, so since time is also short, also a little bit into what we did at the re-ranking space. As you know, usually when you do retrieval, the results are okay-ish, right? But the re-ranking basically help us to give the most sweet spot, right, in terms of precision here. And the way how it works basically is you retrieve some documents, right? They have some similarity score, they already reordered, but then when you re-rank, basically, you know, you have a re-rank score as well. So it's basically a two-stage approach where basically you try to increase the precision. Here, basically, re-ranking, it's always a trade-off between speed and performance, right? So there's so many open source models out there, but also models that you can fine-tune. There's no right and wrong in this case, right? So you need to look at what kind of model works well for you, but also what is the accepted speed, right? So obviously we could have take the best re-rank model out there, but in terms of user experience, that would not be good, right? Because then a user would maybe wait 10 to 15 seconds before the user would get the results, right? So that's why, in our case, we decided for a more lightweight model, right, where precision is still good, but speed is, like, for example, 1 or 2 seconds maximum. Yeah, if you are interested, you can check Sentence Bird on that, right, where you get more information on that. Then another thing that was very important for us was the speed, right? So as Dennis said, we are on AWS Lambda. AWS Lambda is obviously not the most optimized hardware. In this case, it's Intel chips. And here, obviously, if you just use Sentence Transformer, natively, it's not really optimized for that. That's why we wrote our own inference layer on OpenVINO, which is catered for CPU chips. And there we basically also had to have a trade-off between the batch size that we take into the inference layer, but also the token length here as well.
All right, a little bit about our filtering in addition. So we do semantic search, but that is not nearly all of it, right? You have a lot of structured data already, either because we extracted it or because the customer brought those to us. For example, flight data, these kind of things. There might be tags that they added in the system over the course of working with these. And we have the challenge to turn all these things into something that in the end spills out the right result, right? Where you have to combine the AI search, the semantic search with all these filters. And how does that work? So you can see at the top there's a little bit of what the UI looks like for the end user. They basically express their search intent in DNF. Which we chose because it's the most flexible way that is kind of intuitive still to understand for people. And it also translates nice into some JSONs, just an array of arrays, right, essentially. So that's being sent to the backend, and then this is where the magic happens in the filter service, where each of those 35 plus attributes, the different operators like in, not in, they all require different handling, right? You might need to do a join, you might need to do a subselect, all sorts of really complicated things to combine to then in the end, via SQL alchemy, spit out the query that then spits out the results. And we really quickly reached a point there where the complexity is so big that even though all the test coverage is there, it's kind of hard to get all the data in that replicate those, right? So you quickly end up in a point where you change one thing, improve the performance somewhere, but then you might break something else somewhere else. So we're experimenting already with switching to different technologies. And also from the user's perspective, while DNF is kind of easy to understand, it's still tricky sometimes. So we experimented with a natural language processing where we essentially feed an LLM with all the context of all the different filters, what these mean, what these attributes are for. And what it then does is you just give it a text and it spits out the filter structure. That actually works surprisingly well. And so we can bridge the user gap as well to our system, essentially. And we're running out of time, so I think I'm going to skip this one here. Yeah, I'm just going to skip this one. Maybe we have time for a demo.
Yeah, let's do one short demo.
Yeah.
So let's give us 2 more minutes.
So
we have usually content for much more time. But,
right, so maybe just the AI search here because it's kind of cool to show. So let me just say, maybe show me all flights from Zurich. Let's see, so that's being sent now to the backend. This is a simple one right now. You can see departure or arrival airport Zurich. And then if I'm okay, this is kind of nice, but I actually want to have also limit to ones relating to fatigue. Right, as I said, fatigue is a very important aspect that people need to analyze. And then, so the current filters are being fed to the machine, and there you go. It figures out that, okay, there might be different ways how you can describe fatigue. There's the AI search here, text similar to it, and then we have these different classifications as well, which are just figured out, okay, this is stuff that we want to use. And then, boom, this is your results.
Okay, yeah, let's go to the summary, or basically what are our next steps. As I said, from our philosophy, we wanted to have something simple so that we can test it with users and we manage it, right? So the feature was really like welcomed by our user, but as already Dennis said, right, with the filtering and with all the complexity that we had to build, we kind of basically hit that bottleneck or this ceiling where we thought about, hey, we are actually building another search company, right, instead of filtering, focusing on building the product. That's why we also decided, hey, we need a more mature setup, right? Going to open search. Obviously, we also experimented with Tran, Weaviate, and so on. But in our case, the filtering component was also very important, right? So hybrid search is one of the core attribute for us to decide on that. And as you can see, search is not just AI and you know, just doing the fuzzy and the text search, but it's a combination of search and filtering, which makes basically the success of this project. Yeah, thank you for your time, and I think now it's time for questions, or okay.
Thank you very much. So let's directly start with the questions. Is the data traffic you are getting evenly distributed, or are there peak times and low times? And is this something you took into consideration when building the infrastructure?
That depends on the customers. So some, as I said, they have this setup that basically whenever a report enters their own system, it gets forwarded to us immediately. So it's a little bit bound to their flight patterns, but it's relatively evenly distributed. And then we have some customers that, because of their own limitations internally, they just send us data in bulk a few times per day. So there you have these clear spikes. And we basically, yes, we have considered this in our architecture by basically storing these things in queues and like processing them bit by bit, because some of the processing can take a fair amount of time.
Next question. With your architecture, could you share how long is your lead time between document being ingested and being retrievable?
That is a good question. It's not instant for sure, but it's also not that slow. So it depends. I would say roughly.
I mean, there's two components here. The ingestion happens in batch, right? So, and the retrieval is basically when the user would do that, right? So ingestion can take to up to any time, whatever, right? And the retrieval usually should be in the microseconds area.
How do you ensure that the translation to English does not twist information like in the example you gave in the start? Warning was not triggered. Did you encounter any problems regarding that?
Yeah, so this is definitely still a problem that is very relevant because that's really like this challenge that is still unsolved. We have not yet put a lot of focus into this part, particularly for the translations, because we at the moment have the luxury of not actually having customers that really require that deeply. It is a problem, though, that the industry has to solve as a whole. But these days, these models are already like pretty good at things. However, there is always a risk that that information might get lost. So one important thing that we always also tell our customers, it's still very important to have a human in the loop and to not trust everything too much. But it is about gaining all these efficiency extras that you get by processing all these things in bulk. But it is still a problem, yeah.
Well, let's take on one more question. Is the performance of indexing relevant on this case? How did you approach this problem?
Can you repeat the question?
Is the performance of indexing relevant?
What? Yeah.
Indexing performance.
Yeah. What is the question? So.
Is the performance somehow relevant to this problem?
Yes, without index, everything is slow. That's the answer.
Yeah, thank you very much. Give them another round of applause.